in this video, they want us to find P. Okay, so here, ladies and gentlemen, you need to be strategic. Don't be scared when you look this thing. It looks messed up, but it's a very simple thing if you know your story, right? Remember, the first thing you look for is this, the Tn here and the Tn there, right? Perfect. And then I can see that, okay, this is linear. This is linear because t is to the power 1. This way, when this variable being an exponent, so this side I have geometric, right? Perfect. And then this geometric is the sum to infinity, basically, because there's an infinity sign there. So I know that, okay, on the left-hand side, I'm doing sum to infinity. And then on the right-hand side, I'm doing Sn equals to n over 2. Remember, I said for linear, if you have sigma notation, use this formula. Né? Perfect. So I'm going to start this side. Right. I'm going to firstly calculate the number of terms. Remember, it's top minus bottom plus 1. So the top is 12 minus the bottom, which is 1 plus 1. So the number of terms that I'm adding are 12. Right? And then to get A, which is the first term, you substitute the bottom into there. So we're going to have 24 minus 3 and then 1. You can see that we get 21. Right? Then to get the last term, we're going to substitute the last position there. So we're going to say L, which is the last term, is 24 minus 3 times 12. Let's see what does that give us. 24 minus 3 times 12, which is negative 12. So the last term is negative 12. And then we can get Sn now. Ne? Can see that, okay, what will be Sn? Sn will be S12 because the number of unknown terms, the number of terms we're adding is 12. So I'm going to replace that by 12. It's 12 over 2. And then the first term we said is 12. No, the first term is 21, sorry. And then plus the last term, which is minus 12. And then that gives us, let's see. So that 21 minus 12. That gives us 54. Right. Perfect. So the right-hand side, this was the right-hand side, right? RHS. Now let's see what does the left-hand side give us. Left-hand side is basically sum to infinity, right? Of a geometric number pattern. 1 minus R. Let's quickly first get the first term. The first term and the second term, because we'll need to compute R. Ne? The first term will be 27p to the, remember you substitute this there, to the power 1, which is just that. Then the second term will be 27p to the power 2. Therefore, we can see that T2 over T1, which is your R, is the same as 27p squared over 27p. 27 cancels 27. P squared over P is just P. You can see that, okay, the first term is your A, the second term is your R, right? The R is P, so you can substitute there. The first term is 27p, so you have 27p over 1 minus p. And ladies and gentlemen, remember they told us that the left-hand side equals to the right-hand side. So you're going to say, okay, therefore, I have 27p, which is there, and then you have 1 minus p. This is the same as 54. I'm sure it makes sense. And then you can cross multiply now. This there just gives you 27p. You're gonna get 54 in bracket 1 minus p. Then you have 27p is the same as 54 minus 54p. All right. Then you take p that side. Now let's see, you're gonna have 27 plus 54. So 27 plus 54, what does that give us? That gives us 81p. So you're going to have 81p equals to 54. And then you can divide by 81 both sides. So 54 divided by 81, you get 2/3, which is your R. Remember, your R is P, which is, you can see that is true because your R is 0 point something, which means you can have the sum to infinity. That makes sense. Then now we can get what the A is. Remember the A was 27p, which is 27, then 2/3. So our A is 18, ladies and gentlemen. So you have your A, you have your R. So now we can see what they wanted us to solve there. I didn't even read that part. Let's go check. Oh, they just wanted P. Okay, we have our P there. And that's finito with this question, ladies and gents. If you found this helpful, please don't forget to like, share, and hit the subscribe button for more fire content. Aluta continua. Tango.